Hello, good evening to all. My voice is clear. Hello everyone.
Good evening, sir.
Yeah, good evening, very good evening. So, it's my voice is clear. Is my voice is clear?
Uh, uh, okay, sir. Clear, sir. Clear. As I am in journey, even though it is clear, sir.
Oh, okay, sir. Okay, thank you so much. Okay, let us start the session today. So, today's session mostly on this week four assignment solutions. So, in the last week, actually, I think you have been covered that what is stability of the system, like bounded input, bounded output stability, and how the poles and zero will be located when the system will be stable or not. Then stability you have to find out for a transfer function by taking the RS criteria of a closed loop system. That will see some questions on that. Then how to find out the stability of a closed loop system, okay, from the characteristic equations. Then relative stability also concept, how the system will be relatively more stable. Okay, so that part also been covered. So um, I think you have all gone through the last week lectures. So first, anybody can be tell me what do you mean by stability of a system? Means what do you mean by understand by this Vivo stability?
Sir, input is stable, then output is also should be stable. So then it is Vivo stable, sir.
Means input is not stable, sir. Input, if the input is bounded, okay, for any input you have take a bounded system, the output also to be bounded, okay.
Yes, sir. Yes, sir.
And if the
It should
input,
be less than infinity. Infinity.
yeah, means that is called bounded systems. Means suppose your system input will be zero, then output must also be equal to zero. Then you can say that the system is a Bebo stable. You got my point, sir?
Yes, sir. Yes, sir.
uh, so what do you mean by uh, means how can you define this stability? Means how many types of stability are there? Have you have gone through the lectures? How many types of stability are there? Like I can say one system will be stable. Okay, another system will be marginally stable. Another stable is unstable. So we're mainly dealing with stable system, marginally stable system, and unstable system. So what do you mean by marginally stable system? What is the definition of marginally stable system?
When the poles are in the imaginary axis, then it will be marginal stable, sir.
Yeah, that is the definition. But what is your understanding, sir? What is your understanding? Sir, I told you now, for a stable system means if my input is bounded, then output must be bounded. But for a marginally stable, if your input is bounded, but your output always maintain a constant amplitude and frequency of oscillation. Okay, like you can take that the response, suppose the response will be like that, sir, sine omega t. Okay, so this system is not a stable system, it is called a marginally stable system because At every 50 hertz, this frequency is constant, it is repeating, and the amplitude is always constant. The positive half is 1, negative half is minus 1, 1, minus 1, like that. So, what I am giving any bounded input, but your response is coming like that. Okay, like that means it having a constant amplitude as well as a constant frequency of oscillation, then it called a system as marginally stable. Marginally stable means the pole will be definitely on the imaginary axis. Okay, that is the conclusion from this definition. But you have to always ensure that the system has to maintain a constant amplitude and frequency of oscillation. So another thing is there about stability. That what do you mean by relative stability, sir? What is the meaning of this term relative stability? Can anyone please tell me what do you mean by relative stability? Means already the stability term is there. Okay, it means the system. It means a system to be relatively stable. Okay, if first condition is that the system is fast stable. Okay, relative स्टेबल होने के लिए actually the system has to be fast, it should be stability condition has to be satisfied, means the system has to be stable. Then you have to tell that after the system is to be stable, then I can say that how relatively it is stable. Okay, so first satisfying relative stability, your system first satisfy the condition that it has to be stable. Then you have to think about that how relatively it is stable. So that we'll see in this some questions we'll discuss regarding all this. Let me give an example, sir. Okay, so let me give an example. The first question is, let's say square plus 25 equal to 0. Then tell me whether the system is stable, marginally stable, unstable. What is the answer?
It's marginally stable, sir.
How do you know, sir, this is marginally stable?
So,
Because you have solved this and you have got that these poles are located on the
yes, sir. Yes, sir.
imaginary axis, right?
Imaginary
So
axis,
one
yes,
is
sir.
J5, another is minus J5. Okay, fine. Just I'm giving another example set to you. Let me give another example. Let a square plus 10s plus 100 equal to 0. Then can you please confirm that whether the system is stable or not? Yes, you need to solve it in 5 seconds, not more than that. I'm writing the third question. Someone wants to join. The third question is I'm just writing down s cube plus 10s square plus 5s plus 50 equal to 0. Fifth question. So 9 is good for the 2s square plus 8s plus 10 equal to 0. So now you please tell me what is the answer for your B? Stable, unstable, or marginally stable? Are you there, sir? Are
Sir,
you?
three, the CDE I can tell, sir, because input middle product of the middle and outer products comparison, it is greater than middle products are greater than. So it
Right,
is
sir. Right. You're
third
right,
one
sir.
is C. C is this one's marginally stable because same thing is coming,
Right.
and
Good.
D, E are stable, sir.
Okay, sir. Let me generalize at this thing. This is the second order system, sir. Okay. So I'm writing the general formula a square plus bs plus c equal to 0. So this is a second order quadratic equation. Remember that a second order quadratic equation will be stable when a condition is that a b c greater than or equal to 0. So this is the condition for a second order system to be stable. And if your b equal to 0, then it is marginally stable. Similarly, I am just taking a third order system, sir. A s cube plus bs square plus cs plus d equal to 0. I already told you that if the inner product is greater than the outer product, the system is stable, and if it is equal, then marginally stable. If it is less than, then the system is unstable. I'm just trying to prove it by using RS criterion. If I draw out the RS criterion of this equation, then the first term SQ term and S square term and S to the power 1 term will be there. So SQ term will be A and C, and this will be B and D. So S1 term will be BC minus AD divided by B. Okay, am I right?
Sir.
Right.
Yes,
Now,
sir.
to satisfy the condition, sir, means what is the condition of RS criteria? That the first column, all the terms coefficient are either positive or negative. There is no sign change. Okay. So for this third order system, for a third order system to be stable, first of all you will look at the first column. So the first column is this one. So in this first column, A should be greater than 0, B should be greater than 0, and BC minus AD, that product, also greater than 0. Then BC should be greater than or equal to AD. It means we can see that the inner product should be greater than or equal to your outer product. That condition which I already told you, that can be proved from the uh, RS criterion. Are you following, sir?
Yes, sir. Yes, sir. Yes, sir.
Fine. So similarly, you can say that so this system 10 plus 5 is 50 and 50 equal to 50, so it is marginally stable. Then 9 into 72, 72 is less than 100, so system is unstable. And here inner product is 16, 16 is greater than 10, so the system is stable. Right, sir?
Yes, sir.
Now tell me, sir, in this first slide, you know that come to the question bit A. So you are telling that the system is marginally stable. Marginally stable means the poles are located on the imaginary axis. If you go to the first slide, I told you that for marginally stable, the system has to oscillate at a constant frequency of oscillation, right, sir? The system has to oscillate at a constant frequency of oscillation. Now just tell me that in the first beat A, what is the frequency of oscillation? What is the omega value? At which frequency it is
It's
up?
five, sir. Five.
5. Because A is equal to j omega. So that's why the answer is 5. Right? So now sir, you can tell me for the C bit, what is the answer? The omega value?
We have to find, sir.
No, no, no,
Directly,
sir. No,
it's
directly you
not
can say,
possible.
sir. This is a class which you can solve the question in just 2 seconds.
No idea, sir.
Okay, let me tell you, sir. Then just writing up this question on next slide. This is S cube plus question 10s square plus 5s. Okay, 10s square plus 5s plus 50 equal to 0, sir. Okay, so and you can see that the system is marginally stable. When the system is marginally stable, you just imagine that one pole should be located at the imaginary axis. So what is the frequency of oscillation? The frequency of oscillation, so remember that, sir, when your pole will be located on the imaginary axis, can you tell me what is the because pole is located on the imaginary axis means what is the suppose a pole is there, sir, a plus j into p. This is a complex pole because it is a complex pole, sir. But it is lies on the imaginary axis. Imaginary axis means what is the real part, sir?
A.
Real part is 0, sir, right?
Okay, sir. Sir.
Right, because it is lies on the imaginary axis, so a equal to 0. So, sir, for any quadratic equation in terms of s, which term will give you the real part equal to 0? Means real part 0 means you can take that real part 0 means, sir, the even terms, whatever in that equation, the even terms should be equal to 0. Even terms should be not equal to 0, sir. Okay, because why? You can see, sir, SQ, okay, in the SQ if you put a complex number, okay, so the power will come as an odd, right, sir?
Yes, sir. Yes.
Let's say I'm just putting, sir, j2, j2 square, sir, how much? J square into 2 square, right, sir? J square equal to minus 1 and 2 square equal to 4. Just I'm explaining, I'll tell you the concept behind the shortcut, sir. Then if I go to j2q, then I will get jq into 2 to the power q. Jq is minus j and 2 to the power 8. So you just see that these are even terms and these are odd terms. Now you are saying that the even terms, sorry, yes, when a pole is complex, and you are saying that it is marginally stable, it means the real part has to be 0. The real part has to be 0 means the s term only contain the odd parts, s equal to jb. Okay, so it means at which term, sir, in the even term or odd term, where j is there, even term और odd term कहाँ पर j है, sir? Odd terms में है, right?
Yes, sir.
So इसका मतलब, sir, what are the even terms? These even terms does not contain any j terms, right?
Yes, sir.
Right. It means you have to make this. Which part you have to make 0, sir? This odd part, sorry, j part or a real part? Or a part, I mean, you're getting my point. Whether you want to make b equal to 0 or a equal to 0, sir. Where the imaginary term
A0,
is
sir.
not assessed. So make the even terms equal to 0, sir. So even term means
Yes, sir.
10 square plus 50, you make it 0, sir. So how much you will get? S square plus 5 equal to 0. So s equal to plus minus j root 5, right, sir?
Sir, please explain once again, sir. Last point couldn't catch.
Last point you cannot get. Okay, sir. So now tell me, in this equation, to finding out the imaginary terms, so which terms I will make 0, sir? Even terms, right? Are you following, sir?
Sir, yes. Only one even time is there, sir. S square is the only even time.
Ah, 50 into h to the power 0, sir. Don't forget h to the power
Okay,
0
sir.
is
Okay.
there,
50. Yes. Yes, sir.
right?
15 test to the power of 0.
10s square plus 50, make it 0, sir,
Yes,
right?
sir. Yes, yes.
So you
Yes, sir.
find out s equal to plus minus j root 5, right, sir? One point location you get at j root 5, another you get minus j root 5.
Okay, sir. Okay.
You got the point, sir? How can you solve it without finding out RS criteria?
Okay, sir. What about S cube, sir?
Sir, SQ terms should be there, na? Because you are understanding, na? S equal to JB terms are there. Only the real,
Okay, sir. Okay.
because this term even part terms does not contain any J, and marginal
Okay,
system
sir. Okay.
means your pole should be lies in the J axis.
Okay, sir. Okay. Okay.
Okay.
Only S cube and 5S term will be there.
I'm just giving another example. If you are not comfortable with this equation, are not getting. If you're not getting, so then tell me. I'll explain it again.
Yes, sir. Explain again, sir, please.
Right, right. So don't be hesitate to. Okay, because
Am I
some.
audible?
Yeah, yeah, yes, sir. You can audible.
Okay, okay.
Let me admit someone. I'm just explaining it again. Okay. So the equation what I have taken, this is SQ. Let's say what is the given SQ plus 10 square. plus 5s plus 50. This was given to you. So if you solve a arrays criterion, no, then you can easily find out. But it is a time consuming. You have to write two steps. But I am just telling you that first of all, you identify that the inner product 50 is equal to the outer product. The coefficient here is 1. So this product is 50. So you can say that the system is marginally stable. So whenever I'm saying the system is marginally stable, in your mind there are two things will come. First, that my system has to oscillate at a constant frequency of oscillation at the constant amplitude. So how I will find out that constant frequency of oscillation? So to finding out the constant frequency of oscillation, let me explain the definition of marginal stable. The marginal stable says that my poles will be located on the imaginary axis. If my poles will be located on the imaginary axis, let me a pole A plus JB. So this pole is now, when this pole will be marginally stable, it has to go to this imaginary axis. Okay, so it has to go to this imaginary axis. When it will go to the imaginary axis means its real part has to be 0, right? Then your A is equal to JB, it is going to this JB and this is minus JB, because complex poles are always complex conjugate. Now you understand this point, sir?
Yes, sir.
Now you just tell me what is your observation. The observation that whatever the pole is there, the real part has to be 0 for marginally stable. The real part of pole has to be 0. Or you can say, or the second time you can, or in other words, you can say that whatever the pole is there, only the pole has a j terms associated with it. Then that this part has to be lies in the imaginary axis. Let me solve this question. Now you understand the concept. If you understand the concept, now come to the question. In the question, there are there this is a quadratic. This is a okay. Polynomial is given of order 3. So how many poles will be there? 3 poles will be there. So out of the 3 poles, means at least 2 poles are in lies in the imaginary axis. Okay. So how will I check it that? So first of all, let's assume that, so one of the pole is, let's say, let I'm assuming that the pole is J2. Okay. So you already know that the system is marginally stable. So you take the power of the first SQ. When you take SQ, then it becomes j2 power q. j2 power q is jq into 2q, which is minus j8. It means this term is lies in the imaginary axis, because you can see that this pole location is going to here. Okay, then if you find out a square terms, when you find out a square terms of that, then it will put j square into 4, or j square is minus 1. So it means the pole is somewhere here. It is not lies on the imaginary axis. Okay, not light. So this term is not in, this term will be not there in the imaginary axis. Again, similarly, this 50 term also not there in the imaginary axis. So what is your conclusion? The conclusion is that the terms which are having even number of components, even 10 square and 50 is h to the power 0, this does not go to the imaginary axis. Okay, if that does not go to the imaginary axis, if I consider a pole a plus jb, then this part has to be 0. Then jb only exists, means the real part has to be 0. Means I am just saying that only the terms which are having even number of terms, they are the real parts, and those who are having the odd power, they are having the imaginary parts. So what you do, so a pole should lies on the imaginary axis, means the real part has to be 0, means the real part is given by the even number of terms. So whatever the even terms are there in the equation, make it 0. If make it 0, then you will get s equal to plus minus j5. Okay, so this means s equal to plus minus j omega. So your omega equal to root 5. So this is your frequency of oscillation. Got my point?
Yes, I got your point. Uh, One thing, why you have
Yeah.
taken s equal to j2?
Sorry,
Second, why you have taken, sir, s equal to j2?
sir, your
Second line.
voice is not coming. Please louder.
Sir, please explain by writing, sir. SQ plus 5s.
SQ plus 5s.
You are telling that only R terms will have J term, so that
Yeah,
as S cube term and five term will have J term. That's the thing, sir.
yeah. Every odd term is having imaginary parts, and every real I mean, these powers are even. They doesn't come to the imaginary axis. They are the real parts. Always they're having the real parts. You can
Okay.
imagine
Only
yourself.
five will be there, so that five frequency will be
No, you just
minus. Yeah.
for this equation to find out the frequency of oscillation, you just need to equate the even terms equal to zero, sir.
Okay, sir. Even terms are equal to zero, but odd terms are to be taken.
All terms are already there, sir. Means all terms contribute in the imaginary axis.
Okay, sir. Okay. Then how you have arrived at J5, sir? Five is the frequency.
Sir, you cancel
Five is the
na 10
oscillation.
here 5, sir. Just cancel na, sir. 10s square equal to minus
Mm.
58. So this cancel na, sir. S square.
Okay. We have to equate the imaginary even terms. Then okay, sir.
You
Okay.
just
Right, sir.
solve this equation, sir. That's it.
Okay, sir. Okay. Right, sir. Right. Thank you, sir.
Yeah, I think everyone clears. Okay, actually why I'm giving this concept, because this is only a cubic equation. Whenever you have a fifth order equation, seventh order equation, then it's this trick will help you to find out the really to help you to find out the omega value. Not you know no need to solve a seventh RH criteria, seventh order RS criteria. Okay, so I'll give some examples on that. Okay, so don't be worried. Just remember this concept. Now, can you
Sir,
solve?
here root 5, sir. Here imagine root 5 is the
Root
oscillating
5 is
frequency.
the frequency of oscillation, right? Sir?
Okay, sir. Okay. Then. For 10s square is it to be equal to minus 50, then s
Right,
square will be minus 5. Okay, sir. Okay.
right, sir, right. Now you can tell me, sir, what is the answer of this question? Select all possible pole location which corresponds to Vivo's stable system. So, what is will be the answer out of these four?
So we are not changing the screen, sir.
Sorry, not sharing or not visible, sir.
Only one screen is all questions are not seen, sir.
Just a minute, sir.
Whatever the screen you are working, it's the only visible, and all other screens are not visible, sir, at present.
Now I think it is visible.
Yes, sir. Yes. Now
Yeah.
the question is visible, but it is very small, sir. Please expand it, sir.
Okay. Let me do that.
Nothing is seen, sir, actually.
It's an easy question, but for understanding. Now it's clear. This one I'm saying A, this one
Yes,
is
sir.
B,
Yes.
this one is C, and this one is D. So read the question, sir, and tell me the answer.
Sir, B and D are stable, sir.
This one is stable, this one is
B, sir,
stable,
B.
right?
Yes.
And this is, you
A
can
is not
say,
stable.
not stable, and this one also is not stable.
Yes, sir.
Very good, nice. Let me give a question. Okay, let me solve a tricky question. S4 plus 2SQ plus 3S square plus 4S plus 5 equal to 0. Sir, can we tell me that whether the system is stable or not? So I'm writing quickly because for a fourth order system there is no shortcut. You need to write the RS criteria. Okay. So S4 SQ S square S to the power 1, okay, and S to the
The
power 0.
shortcut is only available for third order systems, third
Because
degree.
for third order system we can generalize it. Because for fourth order system, see, I'll tell you how to write this in smarter way, but there is no shortcut, so you have to solve it. But solving the also requires some technique. How quickly you are solving, that's important here. You just to feel it, I'll tell you sir, how you'll solve it quickly.
Okay, sir.
Let's see, S4 coefficient here is 1, then even term coefficient is 3, another even term coefficient is 5, okay, because this is S to the power 0. Then all term coefficient you write down sir 2, and this is 4, and there is no other odd term, so you make it 0 right there. You just fill the gap first. And what I'm telling you sir, remember that whatever this fifth term means the last term, okay, this diagonal, this diagonally terms are always same, remember. Okay, I'll say why on the last. After first solving this, I'll tell you the shortcut here for some times. Okay, so now find out what is S square terms. S square terms is first you multiply 2 into 3, so 2 into 3 minus 1 into 4 divided by 2. Okay, so 6 minus 4 is 2 by 2 equal to 1, so this term is 1 sir, right? You got my point sir?
Yes, sir.
Then for the second term, don't write anything. Whatever the 5 is there, just write down this 5, because this will diagonally, it will come same. Means S fourth, here this is a even term, this is a even term, this is a even term. So this even term ka last term becomes the second even term same, and this become the first even term. This will be diagonally always transferable sir. These are same. I'll solve many questions. Okay, don't do this. Just remember. Otherwise, you can find out by yourself. The same answer will come. This will be 5. I'm just writing quickly. So these diagonal terms are same. Then finding out what is s to the power 1. So 1 into 4. 1 into 4 minus 5 into 2 divided by 1. So 4 minus 10. That will be minus 6. So this term will be minus 6. Right, sir? Got my point?
Yes, sir.
Okay. Then you can see that in the first column there are two sign changes. From 1 to minus 6, this is positive to negative. Again from minus 6 to 5, another sign change. So one sign change, I am saying 1 is positive, minus 6 is negative. So one sign change. Again from minus 6 to 5, another sign change. So there are two sign changes. As there are two sign change in the first column, so there are two poles lies in the right half of S plane. So the system is not stable.
Right above the right side of the right hand
Sorry,
side of
sir.
the screen.
Sorry.
Sir, you said right above.
No, no, no. I'm just writing there. So how many sign changes are there in the first column?
Two sign changes.
Two sign changes means if it is your okay, if it is your S plane, in the S plane, this is called the right hand side of the S plane, sir, and this is the left hand side of the S plane, right? So for system stability, all the poles should be located on the left hand side of S plane. But are there two sign changes? So there are two poles should be on the right hand of the S plane. So maybe these poles are somewhere here, sir, on the right hand side. I don't know, but where? It may be imaginary, it may be on the real axis, but it is on the right hand side. How I can conclude that? Because there are two sign changes. So as the system has two sign changes, so two poles should be lies on the right half of the S plane. And when a pole lies on the right half of the S plane, the system is unstable. So I'm saying that the system is not stable, and that is I can conclude from the RS criteria. You got my point, sir?
Yes, sir.
Okay. Now let me solve quickly another question. Okay. Now you solve this question, sir. Question number 3. And tell me what is the system is stable or not?
Sir, please expand the question, sir.
Question. Okay. Oh yes. Sure, sir. Yeah. Now okay. Visible. I think.
Yes, sir. Yes, yes, yes.
Uh, Read the questions clearly because you don't miss it. Actually, it is asking that for this unity feedback system, find the closed loop system stabilities, and the question is given in the open loop transfer function. So you need to find out the closed loop transfer function. So CS
Yes, sir.
divided by RS is nothing but, I told you
Yes,
in the
sir.
shortcut, 2s4 plus 5s3 plus s square plus 2s. Whatever this
Plus
1
one.
is there, just write down. Yeah.
Yes,
So
sir.
the
Yes,
characteristic equation is now 2s4 plus 5s3 plus s square plus 2s plus 1 equal to 0. And write down the RH criterion here. S fourth, s cube, s square, s to the power 1, s to the power 0. So s fourth will be 2, and this will be another 1, and 1, another 1 is there. So this term, and this term. And remaining terms will come in the odd parts. 5,
Sir, one thing, when we find the characteristic equation, so
right.
for 1 plus GSHS, 1
Yes, sir,
plus
1. Yes, 1 plus
GS.
GSHS. So this is
So,
your GSHS, sir.
GSHS.
Yes. This is the closed loop. This is the loop transfer function, GSHS. Because this is like that, sir. Characteristic equation is telling that this will be GS, this will be some HS. If you find out the characteristic equation, this will be
1
how
plus
much? G
GSHS.
divided by 1 plus GH, right?
Yes.
So you have to make this denominator part equal to 0. So 1 plus GH, right? And H is your unity feedback system. So H is 1, right? So G divided by 1 plus G, you have to make it 0. So got it, man?
Yes, sir.
Yeah. Now you solve here. So what is the remaining terms? One is 5, another is 2. So 5 and 2 you write down. Next, nothing is there, so 0. Now you see, I told you S4 ka third term will becomes here, and this will be 1. So we can write down directly. This will be diagonally transferable. Then you need to find only two S square terms. So 5 and minus 4. Okay, so 1 by 5. And the next term you need to find out, sir, how much? S cube is 2S. So 1 by 5 into 2. 1 by 5 into 2 minus 5 divided by 1 by 5. Okay, so it will be 2 by 5 minus 5 divided by 1 by 5. Okay, so it will be 2 minus 25. Okay, so clearly I can see that this term is negative. So sir, no need to find out the value, but quickly we are going to solve the questions. Okay, whenever going to solve the question, we just to know that whether the sign is positive or not. So just to see that 2 by 5 minus 5, 2 by 5 is 2.5 minus 5, that term is negative, so write down negative. I don't know what is the value. So now you check the sign changes. Here are two sign changes. Okay, so one from here to here, another from here to here. The two sign changes means the system is definitely unstable. The system is not a stable system. Got my point, sir?
Yes, sir. Please wait, sir. Wait.
Yeah, right. I'm waiting.
Yes, sir. Actually, sir, your speed is very fast sometimes. We are sometimes we not catch.
Okay, whenever you did not catch, just ask me to stop this. No problem.
Yeah, yeah. Actually, yes, sir. Yes, sir. Okay, sir. Okay, now. Thank you.
You
You can
got it, sir?
continue.
You got it? How
Yes,
to
yes,
solve the question. Let
yes.
me solve a different type of question now. From see, sir. Till now, what you see that all the coefficient in the first column need to be have positive sign, or whether it has to be negative sign. There no sign changes. So if I give you some question like that, let me say, sir, S. I'm just I'm just writing. It is S5. This is S4. This is S3, S square, S1, S0. Okay. Question I'm not writing. I'm just writing the in terms of positive and negative. So minus, 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 minus. The first column. Can tell me any in the system is stable or not? This is the first column I'm writing.
Once repeat, sir. Sorry.
So this is some characteristic equation is given to you of fifth order, right?
Yes, sir.
And because I have written S5. So some characteristic equation is given to you, that is a fifth order equation. But after finding out the RH criterion, you are observing the pattern like this. The pattern is like that, sir, all the terms in the first column are negative. Then tell me whether the system is stable or not. Means after you solving, this is the pattern is coming.
Okay,
All,
okay. Actually, as per criteria, there is no sign change. We
yeah,
may say,
whether
if,
the system is negative or positive doesn't matter. Our
yeah, yeah.
aim is that all the terms should be exist and there is no sign change. So here there is no sign change, the system is stable. Right, sir? You got the point. So don't be confused that if negative sign will come, the system will be unstable. There should not be any sign change. And all the coefficients should be there. Let me give an example. Let me S4. Here writing S4 plus 2S cube plus 2S square, and for 4s plus 8 equal to 0. Now you solve this question. I'm just writing down, just slowly. You just try to understand. Here I'm writing the even terms. So even terms, this one, and this one. So 1, 2, and 8. And the remaining terms will be going to the odd parts. So this one cross, this one cross. So it will go to 2 here, another 4 here, and nothing is there. So write down 0. So first of all, you have to write like this. Then s square terms. So this 8, whatever this 8 is here, this will come here, and
Yes,
again
sir.
it will come here. Okay. Now we need to find out s square terms. So 2 into 2, 4 minus 4 by 2, this will be 0. Whenever a 0 will become, sir, just stop there. Okay. Because you cannot calculate this term when this term will be 0. So whenever in a RS criterion you are encountering a 0 in the first column, replace that 0 by a small quantity. Small quantity generally, sir, we are representing by epsilon. right?
Yes, sir.
So I'm just replacing this 0 by a small quantity epsilon. Okay, so this 0 I'm removing and writing down epsilon. Now you solve, sir, finding out this next coefficient. So epsilon into 4 is 4 epsilon minus 8 into 2 is 16 divided by epsilon. And how to find out this value? Just put limit epsilon, very small value na sir, so tends to 0. That's why you just finding out the limiting condition here. Now you tell me, sir, what is the limit of this equation? So you can write down limit epsilon tends to 0. So I'm just separating here. So 4 epsilon divided by epsilon minus limit epsilon tends to 0, 16 divided by epsilon. So here epsilon get cancelled. So this first term will be 4. Second term limit epsilon tends to 0. When I put epsilon equal to 0, so this value is going to infinity. So 4 minus infinity is something minus infinity. So you observe that this term is a negative sign. My aim is that whether I need to find out that term is a positive sign or negative sign. So I got a negative sign. Just put a negative sign. So now you tell me that how many sign changes are there.
Two.
Yes,
Two, sir,
because
two.
yeah, from epsilon we are assuming a positive small quantity. So here positive to negative one sign change. Again from negative to positive another sign change. So there are two sign changes. It means two poles out of the four poles. So how many poles are there in the characteristic equation? Four poles. Out of the four poles, two poles are lies in the right hand side. Another two poles are lies in the left hand side. So that is the way. And when two poles are lies in the right hand side, the system is unstable. Clear my point, sir?
Yes, sir.
Okay. So on
Sir,
this,
one query, sir.
yeah,
From the sign changes in first
yes.
column, you can say yes. Number of sign changes in first column.
Sir, your voice is not coming. Please louder.
Yeah, yeah. Actually, as per Routh's stability criteria,
Yes.
the number of sign changes in first column is equal to the number of poles lies in the right half of S plane. Okay.
Right, right, sir.
Okay. So two poles are in right half of S plane.
Right, sir.
But how can say remaining two poles are in left half of S plane? It may be the on the imaginary axis also.
Uh,
Remaining two poles.
yes, sir. It's very good question, but it will not lies in the left hand, sorry, imaginary axis. Why, sir? Because by looking at the RS criterion, there are some conditions. So the condition is that when you are solving a RS criterion, when one row, when you're solving sir this equation, means this question, if this a square, because you are encountering that in the a square column on the a square row, one zero is coming, one from the first column zero is coming, but the second column zero is not there. If that is zero, then you can say, sir, that the out of the four poles, two poles lies in the imaginary axis, because when you are encountering a row of zero in RS criterion, then that means above that means a square terms is zero, sir. It means two poles should be symmetrical about the origin. Symmetrical about the origin means it can be symmetrical like that. It can be symmetrical like that. It can be anywhere, but whenever you're not encountering a row of zero, then definitely there is no possibility that the poles are lies in the imaginary axis. So
Yeah,
that point
thank
you
you,
have
sir.
to remember.
Yes, sir. Thank you, sir.
Right. I'll solve the question. I'm just taking your questions now. Let me give an example. Just few questions. Uh, Let me give an example. S fifth. Let's say S4 3s cube plus 3s square plus 2s plus 2 equal to 0. Now, tell me, sir, what are the pole location we want to know? How many poles on the right hand side? How many poles on the left hand side? How many poles on the imaginary axis? That's it. So you will solve it by RS gradient. So write down the coefficients are S5, S4, S3, S2, S1, S for 0. Then write down the coefficient of odd parts. This one is odd part, so 1. Another is 3. You can write down 3. another this one 2, then write down 2. So remaining I will go on to the next row. So 1, then again 3, again 2. Now you just tell me what the SQ row will come. Whenever two row are same, definitely this row will be 0. You solve it.
Yes, sir.
So now whenever you are encountering a row of 0, then how you proceed further? You cannot proceed further. Then how, you have to replace this 0 by small one. Just you remember that in this question, this row is coming 0. So I'm writing down this row is 0. Okay, this row is 0, but I cannot go for forward calculation by putting 0. So I have to replace this value. How to replace this value? So you write down here. Here these are the even terms, right? So here it will s4 will come. Here s square will come. Here s square will come, right? 0 will come, right? That's it, right? Are you following me? This row is an even row, right? Even row. This is an odd rows, right? So I'm writing the
Yes,
even columns here. S4 means this is S4th row. The first will go for S4. Next is here these terms are right. Okay, you got my point, sir? How I'm just
yes, sir.
right. I'm just writing down S4 again. This is S square. This is S square S0. Just to multiply the coefficient with the power. Coefficient is 1. Power is 4. Write down 4 here. Coefficient is 3. Power is 2. Write down 6 here. Coefficient is 2. Power is 0. So write down 0 here. Next to proceed further, okay, for calculation, I'm just removing this as power here. Then we'll do the calculation. So 6, this is 6 minus 12. So this term is negative. So how much this value will be? This is 4 into 3 is 12. 12 minus 6 by 4. 12 minus 6 is 6. 6 by 4 is 3 by 2. Okay. Then this, what is this value, sir? I told you this value will be, whatever the 2 will be here, it will come here. Right, sir?
Sir, once repeat in front of S3, you have repeated number 460.
So here in the which column is 0, sir? This column is 0, sir, right?
Yes, yes, sir.
Whenever it's 0, you cannot calculate for proceed. You cannot proceed because you are getting one row 0, sir. You need some value to calculate other values. So what you do, you go to the above. The above is called this above equation. This is the even terms, right? You can see the even terms. You find out even terms, you write down, put the even values here. The coefficient just write down, sir. Multiply the power with the coefficient. Power is 4, coefficient is 1. So write down 4 into 1 is 4. Power is 2, coefficient is 3. So 3 into 2 is 6. Power is 0, coefficient is 2. So 2 into 0 is 0. Write down
Yes,
460.
sir. Now got it, sir.
Okay. नेक्स्ट यू नो दैट आई टोल्ड यू सर एस फोर्थ का लास्ट वाला जो होगा 2, वो एस स्क्वायर का ये वाला यहाँ पर आ जाएगा और यहाँ पर भी आ जाएगा.
Yes, sir.
Then you need to calculate only S1 term. So S1 term you just calculate, sir. 3, just multiply like this. 3 by 2 into 6. Then again this one, my 4 into 2 is 8 divided by 3 by 2. Solve this value. This will be 3. So this will be 9 minus 8 is 1 divided by 3 by 2. This will be 2 by 3. Now it is clear, sir.
Yes, sir.
Now you tell me the system is stable or not, sir.
System
Stable,
is
sir.
stable. Stable. No sign changes as per Rawat security
No
criteria.
sign changes, sir. No sign changes, sir. Sign changes are there, sir.
It's no sign changes, sir. But I told you that whenever a row of 0 is occurs, remember sir, this line. I'm just writing down this line for you.
Marginally stable.
No, no, don't say sir. Don't conclude like that. I'll just write down. Whenever a row of 0 will occur, then the poles will be symmetrical about the origin. Did you write down sir this line?
Yes, sir.
Now you have a question. Now you can ask me, sir. Uh, Whenever a row of 0 will occur, then the poles will be symmetrical about the origin. But which poles, sir? How many poles will be symmetrical about the origin? So that pole will be decided by this characteristic equation. So remember that which row is 0. So this row is 0, sir, previously. So above that 0, this power h to the power 4. Okay. This line which you have solved before. Okay. Like 1, 3, 2. So I have written 1s cube, 3s square, 2s. Okay. So if you add this and make it equal to 0 and differentiate this equation, so you'll get 3s square plus 6s plus 2 equal to 0. Then these are the coefficient we have put in there. Okay. So,
Sir, 1s to the power of 4, sir. You are taking wrong equation. It's not
ah,
1s cube, sir. It's 1s 4.
right, right, sir. 1 is 4. So it will be, the differentiation is how much, sir? 4s square. Now, what is the differentiation of this s fourth?
4s cube, sir.
4s cube. So the coefficient is 4. Okay, here the coefficient is 6 and the coefficient is 2. Okay. No, the differentiation of this, I just 1 minute, sir. I just think I'm doing something wrong. So this above equation is a characteristic equation. The characteristic equation is given by your S4 plus 3s square plus 2 equal to 0. This is called the characteristic equation, and differentiate this equation, you will get 4s cube plus 6s equal to 0. So the what are the coefficient? One is 4, another is 6, another is 0. So I have written here 4, 6 and 0. I just told you by using some shortcut, but this is the way you have to arrive at the coefficient 460. So it means which row is 0? Above of that means, so here SQ row is 0, so S4 term. So 4 number of poles should be symmetrical about origin. That's the idea, sir. So out of 5, your 4 number of poles should be symmetrical about the origin because your characteristic equation is this line, this row. So out of 5, your 4 will be symmetrical. Out of 5, your 4 will be symmetrical. Now you just decide that where it will be placed. It can be somewhere here. It can be here. But this system is stable, so it should not go to the right hand side. But there is no sign changes, so there will be no marginal stable concept because all the coefficient in the first column are positive. The system should be stable. So either it can be placed like that, symmetrical. So either it can be placed like that, sir. So you cannot say anything. And another pole can be lies somewhere here. 5 poles. You got my point, sir?
Yes, sir. One thing. Hello, am I audible,
Yes,
sir?
sir. Yes, you are audible.
Yeah, already it would say whenever a row of zero will occur, then poles will symmetrical about the origin. Okay.
Right,
So the number of poles right in the left half of the plane
right, sir.
gives equation above the rows zeros.
Right, sir. Right.
X power 4 means 4.
right? It means out of 5 poles, 4 will be symmetrical about origin. That is the concept.
Yes. Okay.
Okay, but you see that the first column is positive, so the system is never be unstable and the system is not a marginally stable. As our first row is coming positive means you have to place out of that 5 poles in such a fashion it should be symmetrical about origin. You got my point, sir?
Yes, sir.
Sir,
Yes, sir.
symmetrical about origin means it has right side and left side, sir.
No,
Up and
no,
down
no.
also can take
Symmetrical
equal, sir.
about origin means this is symmetrical, sir, right? This is also symmetrical,
Okay, sir. Okay, okay, okay. Right, right.
right? Let me give another question, sir. A very interesting question. Not this one. I'll solve this question later. I'll come back to this. Let me give an example. Mm, Let me give it like this: S7, S6, S5, S4, S3, S2, S1, S0. I'm just writing out the sign. Okay. So I'm writing minus, plus. This row will be 0, 0, sir. Then again plus. Then again plus. This one is plus. This one is minus. This one is plus. Sir, you are solving a question. Let's assume that you are solving a question of seventh order, and you are getting the first column like that, and also in the first column you are getting like this. Okay, and also you encounter that when you are solving the question, one row of zero is occurs, and this is the fifth. This row is zero. So now tell me what are the pole location. So how will you solve this question? So first of all, you identify that, sir. First question, first point, that how many sign changes are there?
Three, sir. Three sign changes are there.
There are here one sign changes, another sign changes plus to minus, another is minus to plus. So there are three sign changes. One sign change, another sign change, another sign change. Okay. So now you are observing that this row is zero. So then tell me that how many poles will be symmetrical about origin?
Six, sir. Six, sir.
6. So 6 poles should be symmetrical about origin, and out of that, sir, you come down. Whichever row 0 is there, this is your baseline. You can see that this is your baseline, sir. One time you have to look down, and the other time you have to look up. Okay. Now you see that, sir, below the baseline, if when you are looking down, there are two sign changes, right, sir?
Yes, sir.
So how many number of sign changes are there in the below down? It means you're saying that, sir, two poles should be lied on the right hand side, right?
Yes, sir.
Three
And
poles, sir.
no, no, sir. I'm just looking. You're at the baseline and looking down. Don't look off.
Okay,
So
sir.
now you have to
For
solve this.
symmetry, you are looking at that.
Yes.
Okay, sir. Okay,
First you identify
okay,
the
sir.
symmetrical poles which are on the right hand side, sir. So two poles, sir. Let me
Yes,
assume
sir.
that
Okay,
there are
okay, sir.
two poles on the right hand side. Then you can say that these these two poles are lies in the symmetrical lines. Means out of 6 poles which are symmetrical about the origin, and these two poles are in between that. It means corresponding there are two poles will become here, corresponding to that, because these two sign changes are coming below your baseline. Below your baseline means out of 7 pole, 6 poles should be symmetrical about origin, and in that 6 pole there are two sign changes. So and you know that two poles are lies on the right hand side. It means corresponding two poles should be symmetrical about that point, means it should be like that, because this should be symmetrical about origin. Now it is clear this point.
But is it compulsory that you have taken poles as real poles?
No, if you take it imaginary poles also, no problem, sir. Here you can place
Okay,
one,
sir.
here you can place one. So the corresponding
Okay, sir.
point will be come here and it will be come here.
Okay, for simplicity, I have taken as real poles.
Yes, and for simplicity I'm taking. Because I know that the system is unstable. Doesn't matter whether it will be imaginary or real. You got my point, sir?
Sir, out of 6 poles, we have
Yes.
find 4 poles.
Yes, because why I decided 4 poles because if I looking at the down, there are two sign changes, sir. And that two sign changes means 2 poles has to be in the right hand side
Yes,
of
sir.
that 6 pole. And I know that in that 6 pole, these are symmetrical about origin. So it means that 2 poles which are on the right hand side corresponding
2 poles in left hand
symmetrical
side.
poles should be on the left hand side.
Yes, sir.
Now you just tell me, sir, out of the 6 pole, we have fixed 4 poles. Now there are 2 poles is remaining which are symmetrical about origin, right? Sorry, which are symmetrical about origin, right? Got my point, sir?
Yes, sir.
Yes, sir. Yes, yes.
It means now tell me at which position I will keep that, which is symmetrical about origin. Because sir, this is a 6 pole. Now you already told that 6 pole will be symmetrical about origin. Already we have fixed 4 poles. Another 2 pole is there. So to make it symmetrical about origin, where I will keep it?
Up.
Can I keep it here, sir? No, because only two sign changes. We cannot make three sign changes. 3 poles cannot be placed on the right hand side. So by default, you have to place the pole at the imaginary axis. Then it will be symmetrical about origin.
So once repeat, sir, for this last.
Sir, I told you that out of 6 poles, already we fixed 4 poles, right, sir?
Yes, sir.
Now you have only 2 poles left, which should be symmetrical about origin, right, sir?
Yes, sir.
Now at which position you have to place these 2 poles so that it will be symmetrical about origin?
Imaginary axis.
You have to place only imaginary axis. And one remaining pole is there because this is a seventh order system. And you see there is a you have to now look off. Whenever you look off, you see that there is a sign changes. So you have to keep that pole on the right hand side because that is a sign change is there. And for these sign changes, there is no symmetrical pole because it is above the baseline. So don't consider. So just put the pole at the right hand side. So this is your uh, location of the poles. So in competitive exams that this pole location will be given like that. You have to identify appropriate because they will never give you on the exact pole location. They will just giving you the approximate which is correct out of 4. So you need to identify like that.
Sir, to seventh pole on the real axis.
Yeah, it has to be in the real axis because you cannot place complex conjugates. Na, you cannot place a complex conjugate because you require 2 poles. Only already you have
Okay.
fixed 6 poles, sir. Only one pole is there, so you have to by default you have to place on uh, the x-axis only.
Okay, sir. Nice question, sir. Thank you.
Okay. Now another question of similar types. Sir. Just to, if you clear this one, then I think you understand everything. If you did, okay. Let me give another question like that. Yes. Let me give him this one. S7, S6, S5, S4, S3, S2, S1, S0. And here this is given like that. Okay, I'm just taking an advanced question. 2 row is 0, right? So here is positive, sir. This one is positive. This one is positive. This row is 0. Again this is positive. Again this row is 0. Then this is positive, negative, and this is positive. Now you just draw the pole locations. Sir, what is the characteristic equation? First of all, you encountered 0 here. It means your characteristic equation is of order 6. So 6 number of poles should be symmetrical about origin. 6 number of poles, 6 number of symmetrical poles. I'm writing like that. And whenever the 2 row of 0 occurs, the system is by default unstable. Okay, you can conclude like that. But I want to know the poles location. So how you do that? Sir, how many sign changes below the baseline? Hello. Sorry, actually there's my internet problem. Uh, Sorry guys. And from which point you have not able to listen me?
Sir, small doubt regarding question number 4, sir.
Okay.
Sir, question number 4, you have taken 2 poles on imaginary axis. Can't we take complex poles, sir? For those 2 poles as complex poles with the negative real numbers, so that then also it is
It is symmetrical, sir.
symmetry with
But I told you now, sir, when one row of 0 is there, it means the system means one. Whenever one row of 0 is there, means the system has to be means two poles should be on the imaginary axis. One row of 0 means
okay, sir.
the
Okay,
pole
okay.
should be lying on the imaginary axis. Two row of 0 means two poles should be lying on means two poles should be on the imaginary axis. Complex conjugate like that.
Okay, sir. Okay, 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 okay,
So
okay.
now here the same question I am
Okay, sir.
writing frame. Here two row of 0, sir.
Yes, sir, yes, yes. Sir, are you telling anything, sir?
No, sir. Are you able to solve this question or not?
Okay, sir. Because the repeated poles will come, sir. Then.
Yeah, repeated polls will become, sir, but a similar question like the previous. You can solve it, sir. Okay. Just write down this question. Because time is less, so I have to cover another thing also, sir. So this part you understand, sir, how you solve this. You got my point, sir? How you solve this, you understand?
Sir, as two side changes are there. 2 poles said
So two
total six
sign changes,
poles.
sir. Yeah, total 6 polls will be symmetrical about origin. I have written out here.
Yes, sir. Yes, sir. Yes.
And out of that 6 poles, there are 2 sign changes. So 2 should be on the right hand side, sir, first. You just place 2 poles should be on the right hand side. So corresponding pole should come on the left hand side.
Point to baseline
Yeah, your
down.
baseline is down, so 2 sign changes, sir. 2 sign changes means 2 poles should be on the right hand side.
Sir,
And
first row are zeros, so we take the first zeros row as a
yeah, as
baseline.
the baseline, sir, always.
Okay, okay. Because here two rows are zeros.
Right,
Yes,
right.
only one row is zero. Yes, okay.
You got it, sir? How to solve this question?
After 2 rows, we have to take, sir.
Sir, 2.
Then four.
Yes, that's a violation, sir. You can understand that in this question, I have just given this question on in my mind, sir. It is not, but something is there. This is not the actual question, but I am saying that it might be I should have changed my question like that because it is not satisfying that what I'm saying. Let me do here plus. This one is plus, this one is plus, this one is minus. Then this question will be valid, sir, because below the baseline only one sign changes. So corresponding pole you write down. So corresponding pole is this one, and there are 2 rows of 0 means 4 poles should be symmetrical about the imaginary axis. So here you write down 1, 2, 3, 4 like that.
Now
Sir,
it's okay, sir.
And
sir, once repeat, sir, please. Once repeat, sir, by changing
because
your
uh,
sign.
because previously what I did actually here I have put in minus here and plus here. If I did that, then what? How it is invalid our assumption. Our assumption is that whenever out of 6 pole, whenever you're looking at the baseline down, it means 2 poles should be on the right hand side and corresponding pole will be come here on the left hand side, right, sir? But you have 2 rows of 0. 2 rows of 0 means one row of 0 corresponding to one pair of pole on the imaginary axis. So whenever 2 rows of 0 means 4 poles should be on the imaginary axis. If you
Yes,
put
sir. Yes,
four
sir.
poles on the imaginary axis, then 8 poles are coming here. But our question is given on 7th order system. It means that's why I need to change my question. So I just gave it in my mind to
Yes, sir.
acquainted you to this type of question should come in the exam. That's why changing this question to plus plus and minus such that one pole should be symmetrical about origin, which is on the right hand side. I'm removing this one, and for 2 rows of zeros, so 4 poles should be on the imaginary axis. Out of 4, 6 is gone, and remaining seventh pole, so seventh pole should be placed on the left hand side. That's it. Why seventh pole should not be placed on the right hand side? Because in the previous case, if you look above the baseline, there is sign change. But now above the baseline, no sign change. So you have to keep that pole on the left hand side.
If no sign change, then left hand side, right? Okay.
Of course, you cannot place that on the right hand side. Whenever sign changes there, you have to place on the right hand side. Did you got my point, sir?
Yes, sir. Please, please wait, sir.
Okay, okay. Yes, just write down. No problem. These are the things I'm just telling because these are very helpful to solve the question quickly.
Okay, sir.
So let me solve one question and next question. The question is like that, sir. For what value of k the system is for what value of k the system is marginally stable And if the system is marginally stable, find out the frequency of oscillation. System is given, the characteristic equation is given to you, sir. S cube plus 9s square plus 5s plus k equal to 0.
For margin stable product of inner terms
Right,
equals.
product inner product outcome. So k equal to say 45, right?
Yes, sir.
So k equal to 45, and tell me what is the frequency of oscillation. Put k equal to 45 here and make the even terms equal to 0. So 9s square plus 45 equal to 0. So s square plus 5 equal to 0. S equal to plus minus j root 5. So frequency of oscillation omega
Yes, sir.
equal to root 5. So
Good,
this type
yes,
of
sir.
question, whenever third order system is coming, you apply its shortcut and directly write the answer. Next question, sir. I'm writing down. This is plus, this is minus, this is plus, this is minus. This is something given negative feedback 0.1 s, and this is given a unity feedback system 1. So find out the transfer function. This is cs, this is rs, input and output is given, and check the system stable or not. So can you do that in 2 lines? I
First
told you
you have
already the shortcut how to write this transfer function of this equation. So first you write down like that. So 100 by s square is there. So you need to multiply 100 to 0.1s and write down here. Because I just want to solve the first two. I'll just solving the first two. So what is the
sir,
transfer
please
function?
once repeat na sorted method because in last lecture na
You
we
forgot,
couldn't
sir. Okay.
understand. Yes, same
Sir,
concept.
whenever g is there, okay, I'm just taking like that. Let's see, given 1 divided by s plus 1, and here something is given, let's say some constant k. So how to solve this transfer function? First you write down 1 by s plus 1, right, sir? Whatever the g is there, this one you write down. Then you go to the denominator, sorry, numerator, top one. 1 is there, so 1 you multiply with k, write down that value. That's it.
Means in denominator only right.
So in the numerator 1 is there, sir. This one you have to multiply with k and write down here. That's it.
Okay, okay. Means first you write the denominator of the
Yes, of the
open.
upper one means I have written the denominator of s plus 1 first. Then this one you have to multiply with h. Your h is k. So
Means the
write down.
numerator is multiplied by k feedback.
Right, sir. So, yes, yes. If suppose it is 100, then it should be 100k.
100k. Okay, sir.
Like that, sir. Now you solve this equation. First two. First one writing directly at 100 divided by s square plus 100 should be multiplied with 0.1s, so it will become 10s. Right?
Yes, sir.
Now this is the transfer function for a unity feedback system. So then you have to just write 100. So this is the transfer function of the overall system, right, sir? Because for the first two, this is the answer. Now 1
Yes,
is there,
yes.
sir. So you just multiply 100 with 1.
Yes, sir. Yes, sir. Actually, two steps.
Yeah, it's just one step. Khatam. Okay, this is
Yeah,
the
yeah.
transfer function. Okay, so this is a second order system, sir, right?
Yes, sir.
Because the characteristic equation is just a second order system, right? So s square plus 10s plus 100 and all the coefficients are positive. In the first slide I told you, sir, whenever a second order system is there, the system is always stable when the coefficients are positive. So it means the system is always stable, right, sir?
Yes, sir.
Yes, so the system is stable. So you have to solve the question like that, sir. Okay. Let me give another question. Let me give in. This is a tricky question. Uh, the transfer function is given g of s k into s plus 1 s cube plus 6, not 6, this is bs square plus 3s plus 1. So this is the transfer function is given. So unknowns are here k and b. You need to find out. You need to find out these two values. But the condition is given that the system oscillates at a frequency of omega equal to given 2 radian per second. And it is given that for a unity feedback system. So h of s is equal to 1 is given. Sir, can you solve this question in just less than 30 seconds? So write down the transfer function. Apply the shortcut, sir. Tell me. K into s plus 1 divided by s cube. Write down first this one. Bs square plus 3s plus 1. Unity feedback system. Whatever the denominator, just write down denominator. Ks plus k.
Yes,
Got it. So this is a characteristic equation. This term is equal to 0. This will give the characteristic equation. Just s cube. I'm just making coefficient bs square plus 3. I'm taking plus k into s plus k plus 1 equal to 0. So this is a third order system. You know the inner product should be equal to outer product. So b into 3 plus k should be equal to k plus 1. So b equal to say k plus 1 divided by 3 plus k. Right, sir?
yes, sir.
And the
Yes, sir.
frequency of oscillation is given say 2. It means you have to make equal to the whatever the real part, you
Even,
make it equal to 0. So it means I'm writing on next slide.
even part.
Even parts, right? Bs square plus k plus 1. Write down here, sir. Bs square plus k plus 1 equal to 0. So
Sir, one
Bs,
previous slide, sir, please.
previous slide, okay. And this is the equation.
Yes,
Take the even terms, select Bs square plus k plus 1, right, sir?
yes, yes, sir.
Make the Bs square plus k plus 1 equal to 0. So Bs square equal to minus k plus 1. And b into a square equal to, I'm putting s equal to j omega square. So it will be minus k plus 1. And omega is given to you in the question 2 radian per second. So it will be minus omega square. This will be minus k plus 1. B equal to minus 4 minus k plus 1. So b equal to say minus k plus 1 by minus 4. So minus minus cancel. So this will be k plus 1 by 4. So there are two unknowns, two equations you can solve and find out P and K. So this is one relation. In the previous also we get a relation between P and K.
Sir, this is for stable system
Uh,
condition.
yes sir, no. It is not a stable system. Now, whenever it is given in the question, sir, the system oscillates at the frequency of 2 radian per second. Means by default the system is marginally stable.
It is
That's why we are,
marginal, marginal.
yeah.
Yeah.
That's why we are
Yeah.
equating as a inner product equal to outer product.
Yeah. System
Got my
oscillation.
point, sir?
System oscillates means marginal stable.
Sir, I told you Nanda, whenever a system oscillates at a constant frequency, then it is called a marginally stable. This is the definition of marginally stable actually, sir.
Okay,
Is
sir.
we are assuming in our mind that marginally stable means the pole should be lies on the imaginary axis. It will come later, but first case is that it has to oscillate at a constant frequency, like a sine omega t, sir. Like the system is marginally stable.
Okay, sir. Very good question, sir. And
Right, sir. So all sir, whenever you're going to solve a question, they'll never ask you very top question like seventh or eighth or they will never give you. They will give you up to third or hardly fourth or equation. So we need to play around that. Okay, sir.
Yes, sir.
So let me solve some question on the relative stability, sir, because time is less. Okay. So these are all okay. Now can you solve this question? Question number 9. Can you solve that, sir?
it is not visible, sir.
Okay. I'll make it large. Okay. Now it is clear. This is also a good question. If you understand all the things, then I think you can make it correct. Still there is some doubt, then maybe make it wrong.
First we find the characteristic equation.
So you just do
Then
this question because you will be have get a flavor that whether you are able to solve or not. So
okay, sir.
just do it into pen and paper. I'm just writing down, sir. I'm just writing down in shortcut way because I'm just multiplying this 4 kp plus kds divided by s into s plus 2 into whatever the numerator. I'm just writing out in the denominator 4 kp plus 4 kds. If I am in the examination hall, then the numerator part I should not write. Directly I'll write this equation directly. So I'm solving like this. Characteristic equation is this one. You make it equal to 0. Okay, this is your characteristic equation. So s square plus 2s plus 4 kp plus 4 kds equal to 0. So if we arrange this in s square plus 2 plus 4 kd into s plus 4 kp equal to 0. Then sir, this is second order equation. So all the coefficients should be greater than 0 for the system to be stable. It means what are the coefficients are there? This is one coefficient. 2 plus 4kd should be greater than equal to 0, and whatever this here 4kp, this should be greater than equal to 0 sir. So it means kp should be greater than equal to 0 and your
KD is greater than minus 1 by 2.
kd greater than equal to minus 1. This is the answer sir. So these questions are looking tough, but this is only one line answer. Shall I go to the next question, sir?
Yes, sir.
Yeah. You just solve this question, sir. In one line, sir, just solve me.
Yes, sir. Trying.
Write down, sir, in one line. K divided by S into S plus 1 into S plus P plus K. This is. So this is a characteristic question. Make it equal to 0. You should be able to write like this. So I'm solving it. S cube S into S square plus S into S plus P plus K equal to 0. So it will be S cube plus PS square plus S square plus PS plus K equal to 0. So S cube plus P plus 1 S square plus PS plus K equal to 0. Now this is a third order equation, sir.
The inner part,
Yeah,
P plus
P
1
plus
into
1 into P should be
plus
greater than
K.
equal to K, because this question is given as stable system. That's why P square plus P should be greater than equal to K. So which should be the answer? This one is the answer. Said never use for any third order system. Never use RH criterion. That's it.
Sir, I request you, I have joined late, around 8 minutes. So initially you have discussed the first slide regarding the stability.
Okay, sir. Actually, today I
If
stop here
time allows,
because
yes.
tomorrow I have an APS. My annual progress seminar is there, so I cannot. I just don't want to take the class today, but I cannot arrange that. So I'm quickly sir, solving the first two question slides which were missed. So I think all remaining question I think you can able to solve your assignment questions. If any doubts sir regarding assignment question, I already gave my number. You can just ping me, which you if you're not able to solve. So in the first slide I have discussed that they have just given some of the questions like some second order system, some third order system. So how you can solve this stability of this system of a second order system, third order system, okay, by using RS criteria. So let's generalize the statement. Okay, let me here write down. Let me a second order system taking a square plus bs plus c equal to 0. So those persons who are finding out the shortcut, they are not genius. They are just taking analyzing the things and whatever the conclusion that is become a shortcut for all. So this is second order system. If I do this question by RS criterion, then you have to write s square, then s, then h to the power 0, then write down the coefficient of s square. This is 1a, another one is c. It will come like that because first of all you write down all the even terms in one line and odd part whatever is remaining in other line, other row. So s1 coefficient is b, so you write down b. So nothing is there, write down 0. So find out this h0 because already that is discussed in the class how you need to find out this coefficient. So nothing but this product bc
See,
minus 0 divided by b. So it means c. I told you the shortcut that whenever even terms is there, this term is carried forward. Okay. So definitely this will come with c, right? So you know that RS pattern is telling that the coefficient of the first column should be positive. So A should be greater than equal to 0, B should be greater than equal to 0, C should be greater than equal to 0. So that becomes your conclusion that whenever a second order system is there, to find out the stability, I don't record RS criterion. The condition is that the coefficient should be greater than equal to 0. That is the condition for the stability. Now whenever you take a third order system, I'm just doing here, let me ASQ plus PS square plus CS plus D equal to 0. Then apply RS criterion, write down the coefficient here first, SQ, then S square, then S to the power 1, S to the power 0, write down the coefficient. Here A will come and C will come, here B will come and D will come. Find out the coefficient here. So I told you this coefficient will be transferable, so this will becomes D. Okay, same will become here, and this will be BC minus AD divided by B. So apply again RS criterion principle. The first column, all the coefficient, all the terms should be positive. A should be greater than equal to 0 and B should be greater than equal to 0. So this coefficient is greater than 0, this coefficient is greater than 0, and BC minus AD, BC minus AD also greater than equal to 0. It means BC should be greater than equal to AD. It means what is the conclusion is that this inner product B and C for a stable system, this should be greater than equal to the outer product. That is satisfying here. If you're saying it is a marginally stable, means I told you for marginally stable, one row of 0 will be occur. Let's assume in that one row of 0 means BC minus AD, this term is 0. Then BC equal to AD. That's why the system is marginally stable. So in that way, we have derived the shortcut, but this is all comes from the RS criterion. That's it I discussed in my first slide, and based on that, I solved some question by applying this formula. I think hope you will clear, sir.
Yeah, thank you, sir. Thank you so much.
So today, sir, actually I'm stopping because this stability is a very small topic. I'll manage this time with the RH root locus in the next class. I'll take 15 minutes extra time. So I'm stopping. I think this stability part is a little bit easier. You can solve this question by applying these formulas. So try to solve the assignments, and best of luck.
Sir,
And
tomorrow you will take the class?
so tomorrow I am having my annual progress seminar APS here in
Okay,
at
okay.
Bombay. So I need to prepare something.
Sir, on every Monday you will take the class, I think.
Yeah, every Monday my slot will be fixed from 6 to 8, sir. No problem.
Actually, sir, no, for control engineering, there are three instructors are teaching.
Right, sir. Yeah.
Three, yeah. So because a lot of